Welcome to Hartman Math. This is lesson 10.2, Introduction to Conics, Parabolas. So our conic sections are when we have a double napped cone. So it's a cone looks like this, one kind of sitting on top of the other. But the idea is it's not really a cone in a geometry sense because it really doesn't have a true base because the sides keep extending forever and ever. So we're talking about a double napped cone, and when we're talking about intersecting it or slicing it with a plane, so the different figures that we get, if we slice it parallel to the base and not passing through the center, we would get a circle. If we pass it through, not passing through the base but at an angle, we're going to get an ellipse. If we slice it through the theoretical base at an angle, we're going to get a parabola. And if we slice it straight down and not through the center perpendicular to the theoretical base, we would get a hyperbola. Notice there's two parts to it. We call it two branches. So that creates the hyperbola. The degenerate cases are if we pass through the center, you just get a point. If you go right along the edge, you're just going to get a line. And if we go perpendicular but through the center, we're going to get two intersecting lines. So our general form for all of our conic sections is ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. And for our purposes, we're going to have b be 0. So what happens if there is an xy terms, it takes all these conic sections like a parabola and it tilts them in the plane, which definitely adds a tremendous degree of difficulty. If you are interested in that, take a look at section 10.5 in the book. So the definition of a parabola in a conic section sense is that we have our axis of symmetry and we have our vertex. That's true back when we were thinking of parabolas in terms of functions. We have this line, the directrix, it's always going to be perpendicular to the axis. And we have a point on the axis called the focus. And every point that's on the parabola is the same distance away from the focus as it is the directrix. So this distance and this distance would be the same. This distance and this distance would be the same. If we're going out to here, this distance and this distance would be the same. So that defines the parabola. So our equations, in terms of conic sections for the parabolas, if we've got kind of our standard vertical axis, as when we're thinking of parabolas in terms of being functions, they would have a vertical axis of symmetry, and that would make the directrix horizontal. But that's kind of the normal, I say normal parabola, where x is being squared, because usually we would think of like a y equals x squared kind of parabola as a parent function. So in that case, it's x minus h squared. So the x is being squared equals 4 times p times y minus k. And just as before in standard form, the h and the k are the vertex, represent the coordinates of the vertex of the parabola. The p, which cannot be 0, p is the directed distance from the vertex to the focus. So again, p is a directed distance, so it could be negative, from the vertex to the focus. That gives you the value of p. The horizontal, so this one would be not the function, the one that opens to the side, fails the vertical line test, not a function. So the horizontal axis, therefore a vertical directrix, is going to be the y that's being squared. Y minus k squared is equal to 4 times p times x minus h. If we're lucky enough that the vertex is the origin, the h and k are 0, it just kind of takes us down to there. That's just more special case, though. All right, so here's what they look like. We've got opening down, so P is going to be negative. X is being squared because we've got the normal vertical axis of symmetry. Here we've got a horizontal axis, so Y is being squared. And the distance from the vertex to the focus going to the right is going to be positive, so P is positive. And horizontal, so Y is being squared. The distance from the vertex to the focus is going to be going left. So that's a directed distance that would be negative. So P is less than 0. Example number 1, write the standard form equation of a parabola with a vertex 1, 3 and a focus negative 1, 3. Then graph it. Actually, we're going to kind of graph it as we go along. So it might be a good idea to have some graph paper handy as we go through these. The first thing I think we should do is take 1, 3 and negative 1, 3 and plot those on a graph. And when we plot those on a graph, we're going to see the line that would pass through there. It's going to be horizontal. So when we choose which model we're going to use, which equation, one for horizontal is when Y is being squared. So Y is being squared 4 times P times X minus H. So what's P going to be? Okay. So again, refer back to the graph when you plotted these points. We want the directed distance from the vertex to the focus, from 1, 3 to negative 1, 3. So that's going to be going 2 to the left. So P is going to be negative 2. Now you can calculate that here minus here. That's a lot of things to memorize. It's a lot easier just to visualize it on the graph and say, I wanted to go from here to here. I went left 2, so P has got to be negative 2. So I think we're ready for our equation. We've got our H and our K. We've got our P. Let's substitute those in. There's our equation. Now let's complete the graph. So here are the points that we have. Okay. Next thing we want to do is to draw the directrix. So here's our vertex. We went 2 to the left to get to the focus. That means we got to go 2 to the right, the other direction, and we would reach the directrix. Since our axis was horizontal, our directrix is going to have to be perpendicular to that or vertical. Next thing we're going to look at is to get a couple other points for our parabola. So what you want to do is you want to count the distance from the focus to the directrix. It is 4, going horizontally. Then from the focus, we're going to go 4 vertically, up 4 and down 4, and put points. That's just using the definition of a parabola because that point is 4 away from the focus and it's 4 away from the directrix. If it's the same distance from both, it's got to be on the parabola. Same thing here, 4 and 4. So that's why we put them there. We counted 4 here, then we went up 4, down 4, and now we can draw our parabola. Checkpoint. Go ahead and pause the video here as you work through the equation and the graph. So we've got vertex, we've got focus, we went down 1, so P is negative 1, and that's in a vertical sense, so the axis has to be vertical, so that means X has to be squared. So X minus the H squared equals 4 times the P, so 4 times negative 1 is negative 4, times Y minus 2. We want to leave it in this form, our standard form for conic parabolas. Example number 3, find the focus of the parabola. Well, this parabola is listed in polynomial forms. To be able to access all of the important information, we want to get it in the conic section standard form. So either x minus h squared or y minus k squared all by itself. That's our goal. So I kind of like to get rid of this 1/3, so maybe we could fraction bus, multiply everything through by 3. And then since we want x minus h squared, since the x is being squared, we want x minus h squared. We're going to need to complete the square to do it. So we can get rid of our constant and then add a 9 to both sides. So subtract 3 on both sides, add a 9 to both sides. Or another way of thinking of it is, I know I want that to be a 9. That would complete the square. So if I just add 6 to both sides, that accomplishes that. One last thing, or should say 2 last things, we need to rewrite this as a binomial squared. And then over here, whatever the leading coefficient is, we need to factor it out. Whether you think you can, like if that's a 5, we still have to factor out a 3. Because it's the form 4 times p, that's that factor, times y minus k. So we factor out the 3. So here's our standard form. We're now ready to go. We know where our vertex is, 3, comma negative 2. We need to now know what p is, because that's going to take us from the vertex to the focus. That's where we want to locate is the focus. So the 3 is for the 4p. So 4p equals 3. Let's solve for p. We've got our vertex at 3, comma negative 2. X is being squared, so this is vertical. So when we say p is going to be 3/4, that means we're going to, and it's positive, and we're talking about vertical, so we're going to go up 3/4 from here, which means we can add 3/4 to the y-coordinate. So we get 3, comma negative 5/4. Now, it didn't ask for it originally, but what if it did? What if it said, hey, where's the directrix? Okay. Well, if we've got a vertical axis, that means we got to have a horizontal directrix. So it's going to be y equals a number. And if our vertex was 3, comma negative 2, if we went up 3/4 to get to the focus, it means that we would go down 3/4 to get to the directrix. So we're talking up, down, that's the y-coordinate. So we're going to go down. We're going to subtract 3/4 from the 2. And that's going to get us y equals negative 11/4 if we were interested in the directrix. The reflective properties of parabolas. It says the line segment that passes through the focus of a parabola has endpoints on the parabola. It's called a focal chord. Focal chord perpendicular to the axis of the parabola is called the latus rectum. So the idea here is that if we have a light shining and it shines this way, the parabola is then going to focus, or it's going to hit there and send all of these parallel lines like a headlight. So it shines here and then it focuses everything back and bounces the light back here. A reflective property of a parabola, there's another idea here that a tangent line to the parabola, so a line that just rests up against it, touches the parabola at one point, would be the definition of the tangent line there, makes equal angles or congruent angles with the following 2 lines. So the line that passes through P and the focus, that angle, and the tangent line and the axis of symmetry, that angle. What that means, if we think of this focus, that point there where the tangent line intersects the axis of symmetry, and the point of tangency, if we think of those 3 being the vertices of a triangle, this is them because we have congruent angles there. This is an isosceles triangle. Isosceles triangles also have congruent side lengths. So this distance and this distance also. And we're going to use that for example number 4 to find the tangent line, find the equation of the tangent line at a point of tangency on the parabola. So this is a calculus problem that we're going to attack in a pre-calculus fashion. When you do this problem in calculus, it's a lot simpler and a lot faster. So we've got our parabola y equals x squared. It's kind of our standard parabola, our parent function parabola. So we want to maybe think of the graph of that, and then 1, 1 is on that, and that's going to be our point of tangency. So step number 1, to find p. So x squared equals 4py. So there's a 1 right here. 4 times p is going to be that 1, because this is also in conic section standard form. X squared equals 4py. Vertex is at the origin, which we already knew. So we found p is 1/4. Now sketch our problem. So here's our parabola. Here's our point of tangency. You can draw the line. Since p is 1/4 positive, going up from 0, 0, that puts the focus at 0, 1/4. And we have an unknown y-intercept, as the y-axis is our axis of symmetry. So we need to kind of figure out what this is. Well, remember, this angle here and this angle here are congruent, because we're talking about a tangent line to a parabola. And that means this distance and this distance are the same. They're equal. So let's find this distance. Let's use the distance formula to find the distance between these 2 points. If we use the distance formula, or just a version of the Pythagorean theorem, distance squared is equal to 0 minus 1 squared plus 1/4 minus 1 squared, and that would be 1 plus negative 3/4 squared is 9/16, so we would get 25/16, or d squared, or d1 squared. So if we square root that, we're going to get 5/4. So if this length is 5/4, then this length has to be 5/4. So what's 5/4 below 1/4? 0, negative 1. So p is negative 1. Now we can calculate the slope. We can do the slope formula. Or just think we went up 2, right 1, slope is 2, y-intercept is negative 1. The equation of the tangent line, y equals 2x minus 1. And once again, that's going to be a lot easier when you do it in calculus. And that's it for today. I'll see you next time.